So this video is meant to talk about how to find the slope through each pair of points listed in your worksheet there. A couple of things about this set of problems. One thing to remember is you can always go back to graphing, which is why graph paper was provided at the bottom of your sheet. So the first example we're going to look at is one that we can graph easily. So you have your graph set up already. Here's mine set up. I'm going to actually do number 3 first, okay? Because number 3 will help me explain how we simply graph it and we can find the slope. Now number 1 though, if you look up above at number 1, those numbers are much larger and much farther from the origin. So it's going to be a little harder to find the slope by graphing. So let's talk about number 3 first. We'll start by graphing. So I'm going to go to -4, 7. And I'm going to plot my point. Now I'm going to go and find -6, -4. And -6, -4 is, of course, down over 6 and down 4. So now I have my 2 points plotted. Now I need to find the slope between them. So slope, we remember, is delta y over delta x. So I'm going to start with drawing in my triangle, my slope triangle, because I need to find how much delta y and delta x are. Now when I count, it looks like I count 11 up. And remember, this is the line that we're talking about, this line that connects these 2 points. And that's my slope triangle. And I count and I go up 11 to get to the top. So my rise is 11 and my run is 2 because I counted 2 boxes to go to the right. So my slope, remember, is rise over run, or delta y over delta x. And remember, delta y is the change in y. So I'm looking at how much I went up, and I went up 11. And I look at for the change in x, which is 2. So my slope is 11 over 2. I do want to check and make sure it's positive or negative, and in this case it is positive because the line is going upwards. Now let's take a look at number 1. Number 1 is a lot harder to graph. 19, -16. That's definitely off of my graph, and if you check your graph, it's going to be off of yours as well. So I do not want to have to graph this, but what I'm going to do is make a little sketch. I'm going to make a little sketch of this point. So I'm still going to draw little axes, and I'm still going to find and sketch approximately where these would land. And this would be landing it over at 19 and then way down at -16, right? So I'm simply plotting this point on a generic coordinate plane. So it's not perfect and it's not a graph. But I know that it's over 19 and down 16. Now I'm going to plot -7, -15. So I want to keep in mind what I've already got graphed here, but now I'm going to go -7, -15. So I'm going to go to the left 7, because that's -7, and I'm going to go down -15, and that's just above -16. So I've got my 2 points plotted. Now I can think the same exact way, just like I did problem number 3. I just don't have boxes to count, so the next step is where it's going to get a little different. So I'm still going to connect them. I'm still going to connect the 2 points with a line, and then I'm going to draw in that generic triangle, that slope triangle. Okay, I know that it went down from the green point to the red point because it was up at -15 and it went down to -16. So that's why I drew the line going down and then over to the right. So now I need to still find those 2 things in order to find the slope, delta y and delta x. So delta y, that's how much the y changed. So if I look at my slope triangle, that's this vertical side. And notice as well that it's actually looking at these 2 points, -16 and -15. So I'm looking at those 2 points and I see that they only changed by 1. It only changed by 1 from -16 to -15. So delta y is 1. But I have to do the same thing for delta x because it's always delta y over delta x. So now for delta x, remember that's across left and right because x is left and right. And I'm going to count how far across it is. Now I got to be careful here, and I'm going to use my x numbers. I'm going to notice that I went 19 to the right to get to the red point, but I also went 7 to the left to get to the green point. So the total change from -7 to 19, the total change is 7 plus 19, or 26. That's how much the x changed. Because to go all the way from here to here, it would take 26 units. And that's, of course, the same from here to here. So that is my delta x, 26. Last thing I check for is the slope positive or negative? And it looks like the slope is negative. It's going down because the line is going down. So my slope is really tiny, -1/26. Now I know this is a little bit challenging, but you're going to do your best to draw these little triangles and count how much up and how much to the right, or down and to the left, depending on the problem. So the next question, we're going to do one more example. We're going to do number 5. We're going to draw a generic picture of this as well. So I'm going to do the same thing. I'm going to draw a little picture of a coordinate plane. I'm going to count over 17 and then down -13 to get to my first point. And then I'm going to do the same for 17/8. So notice it's got x is 17 again. So I'm going to go over to 17 again and up to 8. There's my line. It's perfectly up and down. It's directly above. The points are directly above each other. So now I got to find the slope. The process is exactly the same. I'm looking for the change in y and the change in x. So I look for the change in y. The change in y is how much did it go up. So I use the numbers -13 and 8. How much did it go up? Well, it went 13 to get to 0. 13 to get to 0, that's the distance here. And then I went an additional 8 to get up here. That's how I did the 8 there. Now I add the two together because all together the change in y is 21. So 21 is my change in y. Delta x is the change in x, so I'm looking at how much x changed. But if you look, they're both 17. They didn't change at all. It stayed at 17. So if there's no change, we use, of course, 0 for nothing. So we have the slope of 21/0. But a slope of 21/0, you cannot divide by 0. It's illegal in math because there's no defined answer for dividing by 0. So this is an undefined slope. And that's one you'll just want to memorize. Whenever your line goes straight up, it's an undefined slope. I didn't even need to count the 21, but we have to get that memorized. Undefined is a perfectly straight up and down line. So do your best to draw these pictures and to count the distance. But in this case, we're not counting as much as adding or subtracting sometimes. So do your best to count the difference between 2 points without actually making a graph. If we need to, we'll go back to graph paper to keep practicing. But I know you've done slope before, so this shouldn't be as hard. It shouldn't be hard to do it on the graph. It should be much harder to do it like we're doing here. So this is the practice we need. So ask lots of questions, do your best, and finish the worksheet.